So, hi everyone. In this video, we're going to discuss naive forecasting using the autoregressive model. So, in a previous video, we did naive forecasting using the moving average model. So, in this video, let's do it for an autoregressive model. So, if you recall, recall, in an MA model, so in an MAQ model, okay, it has finite memory in that the forecasts tend to collapse to the model intercept if uh, if the lag order that you're trying to if the period that you're trying to forecast is beyond the lag order. So say for example you want to forecast 5 periods ahead, the forecast really fails because it will collapse to the value of whatever the estimated model intercept is. Okay, at the fifth lag because you only say use then a model with 4 lags specified to begin with. So it has finite memory and that's a limitation, so to speak. Now, the AR model is different. Okay, the AR model is different, the ARP, in that it has infinite memory. And it may sound a bit blurry now, but we're gonna show it in this example. Infinite memory. It has something called infinite memory. And to do that, let's start immediately with an example. So say we have an AR3 model, AR3, and that looks like YT equal to mu plus phi1 YT minus 1 plus phi2 YT minus 2 plus phi3 YT minus 3 plus UT. So this is how an AR3 looks like. So say I ask you, okay, let's forecast 4 periods ahead. Forecast 4 periods ahead. So again, step 1 is to generate scalar forecasts. And how does that look like? We're going to do YT plus 1, YT plus 2, YT plus 3, YT plus 4. Okay, and this will look like mu for 1 period ahead. So we move each period here 1 period ahead. So this is phi1 YT, okay, plus phi2 YT minus 1 plus phi3 YT minus 2 plus UT plus 1. Then we have mu plus phi1 YT plus 1 plus phi2 YT plus phi3 YT minus 1 plus UT plus 2. Then we have mu plus phi1 YT plus 2, phi2 YT plus 1, phi3 YT plus UT plus 3. Okay, then we have mu plus phi1 YT plus 3 plus phi2 YT plus 2 plus phi3 YT plus 1 plus UT plus 4. Okay, so these are our scalar forecasts. Again, very similar procedure to how we did the moving average model. And similar to that procedure as well, we're going to use the conditional expectation. So we're going to use that again to generate the actual forecast. And so for example, that's again F. So F, say T, that's equal to the expected value YT plus S, conditional on anything that you know at time T. So similar procedure. So let's generate the actual forecasts. So to actual forecast. Okay, so let's start with F1. That's equal to expected value YT plus 1, contingent on everything that you know at time T. That's gonna be equal to expected value mu plus phi1 YT plus phi2 YT minus 1 plus phi3 YT minus 2 plus UT plus 1, conditional on omega T. Okay, then again, spreading the expected value operator, expected value mu, conditional on omega T, plus phi1 expected value yt conditional on omega t plus phi 2 expected value yt minus 1 conditional on omega t plus phi 3 expected value yt minus 2 conditional on omega t plus expected value ut plus 1 conditional on omega t. Okay. We go term by term. This is expected value mu with respect to omega conditional on omega t. That's just mu. Then here, okay, we have yt. We know the value of yt at time t, so that's phi 1 yt. Of course, since we know yt, we definitely know its past value, so phi 2 yt minus 1. And we also know its value 2 periods ago. That's phi 3 yt minus 2. And now, again, we assume that it was a white noise error term, so the mean of a white noise error term, that's just 0. So our first forecast, ft plus 1, is equal to mu plus phi 1 yt plus phi 2 yt minus 1. Okay, so sorry, t plus 1 plus phi 3 yt minus 2. And that's our forecast for 1 period ahead. Okay, now let's proceed to the next one. So for 2 periods ahead, okay, so ft plus 2, this is equal to expected value yt plus 2 conditional on omega t equal to expected value mu plus phi 1 yt plus 1 plus phi 2 yt plus phi 3 yt minus 1 plus ut plus 2 conditional on omega t. Okay, this is equal to expected value mu plus phi 1 expected value yt conditional on omega t. This is conditional on omega t plus phi 2 expected value sorry, this is t plus 1 rather. Let me just erase, make it better. This is yt plus 1 conditional on omega t. This is yt conditional on omega t plus phi 3 expected value yt minus 1 conditional on omega t plus expected value ut plus 2 conditional on omega t. Okay, now similarly, we know this again, that's equal to mu. Let's leave this one for now. Okay, we're gonna talk about that a bit in a very short while. Then we know, of course, the value of yt at time t, so that's phi 2 yt, and we know, of course, the value of yt minus 1 at time t, so we have phi 3 yt minus 1. But of course, we don't know the value of it's a white noise error term. Mean of a white noise error term, that's 0. Okay, now this one is a bit interesting, and it's what gives the finite memory property in an AR model. That expected value yt plus 1 conditional on omega t, that's actually, okay, this value. So remember, we computed for that. Okay, that's the first forecast, the first actual forecast we computed for, right? We computed for that. And what we can do is we can actually plug in, okay, the value of our 1 period ahead forecast to our estimation to get the actual value for our 2 period ahead forecast. So that's possible. So this reduces to mu plus phi 1 ft plus 1 plus phi 2 yt plus phi 3 yt minus 1. And that's our forecast 2 periods from now. Okay. So notice there's that trend. So we're going to start to see a trend already. We're going to start using our previous forecasts to feed into our newer forecasts. Okay. So let's do 3 periods ahead now. 3 periods ahead. That's again ft plus 3. That's equal to the expected value yt plus 3 conditional on omega t. That's equal to expected value mu plus phi 1 yt, that should be yt plus 2, plus phi 2 yt plus 1, plus phi 3 yt plus ut plus 3 conditional on omega t. So doing that conditional expectation, this one, that's just equal to mu, plus this one, okay, the expected value of yt plus 2 conditional on omega t, well, that's our second forecast, our forecast for 2 periods ahead. This forecast here for 1 period ahead, okay, we can plug that in too, so that's ft plus 1. So the conditional expectation of yt plus 1 conditional on everything that you know at time t, that's our forecast 1 period, that's our forecast 1 period ahead, so that's ft plus 1. We computed for that earlier. And then of course we know yt at time t, so that's phi 3 yt. And then our ut plus 3, the mean of that is 0. So this is our forecast 3 periods from now. So 3 periods from now, ft plus 3, that's our forecast. So 4 periods ahead. Okay. So that's ft plus 4 is equal to expected value yt plus 4 conditional on omega t. That's expected value mu plus phi 1 yt plus 3 plus phi 2 yt plus 2 plus phi 3 yt plus 1 plus ut plus 4 conditional on omega t. Okay, doing that same form, ft plus 4, again expected value mu with respect to everything you know at time t, that's just mu, plus phi 1. Okay, again we use the forecast 3 periods ahead. This is yt plus 3, we know that, that's this one here. Okay, that's this one here. Then phi 2, again we still know that, that's ft plus 2. This one we know that again, that's ft plus 1. This one, mean of that, that's 0. So our forecast, okay, our forecast 4 periods from now, that's gonna be equal to mu plus phi 1 ft plus 3 plus phi 2 ft plus 2 plus phi 3 ft plus 1. Okay, we can now see, as you can see, if you try and forecast more and more and more periods ahead, we can generalize, so say s periods ahead. Okay, s periods ahead. Okay, for an AR3 model, okay, this will reduce to ft plus s, so s periods ahead. That's expected value yt plus s conditional on omega t. Okay, and we can see a defining trend as we move to further and further horizons, as we say. So that's mu plus phi 1 ft plus s minus 1 plus phi 2 ft plus s minus 2 plus phi 3 rather, sorry, I was gonna write theta, it's supposed to be phi. So plus phi 3 ft plus s minus 3. So note, for example, we are here at 4. This is t minus 1, so this corresponds there. So 4 minus 1 is 3, so that's why it's like this. Then this one corresponds to that one corresponds to that. So we can start to see that definitive trend. So based on this, okay, so you now know that the AR model has infinite memory because it can keep on recycling the old forecast. So based on this, can we immediately conclude, okay, that the autoregressive model is already better than the MA model? Not necessarily. Okay, so we cannot make that sort of assumption. While the distinction between finite memory and infinite memory may be clear in the examples, it doesn't necessarily preclude anything about the accuracy of the model. Okay, so just bear that in mind. And